Push is fragile and can be blocked by the user. In order for the app to work properly, we need to properly handle the situation where push isn't available, and we can do that with a fallback implementation. I have two such implementations. I will start with the HTTP-based implementation. The async build code needs a place where it can deliver the message sent back to the client. The restaurant entity is pretty convenient for that. We can store the result from the build process in the last result entry within the restaurant entity. You might recall the build app service class, where we send the build async call using a post method. We can just return the response by using a get method to fetch the entity. Database transactions take care of the rest, and all we need to do now is poll from the client for this update. In the client side, the build app method sends a build to the server. Here we have a polling fallback code to see how the connection is working. If we have a push key, we don't need polling as push will take care of this. But if we don't have it, then polling needs to kick in. The polling code is pretty simple. Let's review what we have here. First, we have a request to the build app URL again. This time, however, we pass false instead of true to the second argument. That means we are making a GET request instead of a POST request. We wait for the response and check if it's valid. We then schedule a timer that will keep polling as long as the value hasn't changed. Once that's done, we cancel the time and return the value with on-build result. This isn't ideal, and normally we try to avoid HTTP polling. Check out a better approach demonstrated in the WebSocket version. Thanks for watching. I hope you found this informative.